Hello, and welcome. I'm gonna jump straight into the topic today. I think we should have enough joining and be online, and I think we'll get started. So, as a starting point, thank you very much for joining me today. You're all very welcome. Um, Thanks for taking time on your busy schedules to join us here at Nodes and Links to discuss, I think, some key important subjects. This one here particularly is around the content within a schedule update. It's designed to be a series of webinars. So today we'll talk about the actual content within the schedule update, and hopefully next month we should be talking to you about resource and resource efficiencies within schedules. But as we've got quite a lot to cover today, um, I'm going to get straight into today's subject, which is schedules lie, yours, mine too. As this is the first webinar I'm doing for Nodes and Links, I think it's appropriate that I just take some time to introduce myself. My background is in construction, starting with oil and gas and other EPC projects for oil and gas. I then moved into copper cobalt mining in the Democratic Republic of Congo in a construction company there. I was the regional planner for that, managing a few projects. One of them being the rehabilitation of a mine that was destroyed in one of the wars. Um, and then after mining, I got more into the software side of things as a consultant, but working on platinum mines in South Africa, the nuclear power plant in South Africa, and but more focused on the actual software, not managing projects. Um, then into as a country manager for a platinum partner and the first to implement um, P6 in Unifier on the Oracle Cloud. After that, I moved to the UK about 9 years ago, and worked for a PPM developer there, and now I'm with a wonderful team here at Nodes and Links. I remember my first day on site. I started as a technical clerk, and then I was upgraded to lead field engineer, and I would go around all the different sites collecting the progress from the other field engineers on a flash disk. Yeah, it was done that way. So it shows how old I am. And I would go back up to the main office on the site, and I'd sit with I'd go into this office. There was a planning office. There were three people in there, planning manager, um, and two schedulers, and I would sit with them next to them, and they would take my information from my spreadsheet, and we would update this product called Primavera Systems P3, which again shows how old I am. But I was absolutely fascinated, and I would spend the rest of my life trying to understand that product because it was a difficult product to understand. Took a long time, but really, what was happening was that the planning function just became a checkbox option into project management, rather than the thing that actually drives and steers the ship in the right direction. And it's been my passion ever since is to try and get the power of the schedule in everyone's hands so that they all, they can, the planning team can keep the ship working in the right direction. Obviously, there's other constraints that you manage within in a project, but I felt that planning should play a more vital role and should be more accessible to the everyday team in on a project. Right, so that's a little bit about me. Starting here at Nodes and Links, I was looking at some of the behaviors within Nodes and Links. Now, um, these events, such as today's webinar, one of the objectives is obviously to show the power and value that Nodes and Links can add, but it also provides the opportunity to share some of the observations we have been making in the market, user behaviors in the tool, conversations we have with customers and potential customers, and package it into an hour's webinar to show you what we found. And so, I was looking around, and I did the calculation and worked out that about 12 schedules on average are loaded into nodes and links per customer per month. Some of those numbers are probably a little bit exaggerated because you make a mistake up and you go back and you fix it and you upload it again, or it could be a demo project where it could be testing something, so that it might be a little bit high. So let's say it's 10 projects, and I asked myself, you know why are they uploading 10 schedules per month? Why are they not just uploading one schedule per month for their project? And if they are loading 10, then what exactly is in those schedules? And then using the knowledge I've gained with systems like Microsoft Project or Primavera, plus what I know of nodes and links, I can start to then understand what's not in those schedules, and try and piece together what's in them, and then understand where this is coming from. So to understand what's in them, I first need to understand, the construction of those schedules, and that'll give me a starting point to understand why they're doing that. So let me show you some of my findings. So for the interest of this webinar, I used a Primavera file that was one of the customers had uploaded. I picked it completely at random. I ended up with, I think it was a data center project, construction project. But what we will find later on as I go through this, you'll see that um, 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 that they actually do follow very similar processes or phases within, from a high level, and then they go into provide more detail depending on the industry, but they are quite common to a certain point. And looking at the schedule here, this schedule was a 6-year duration, so I would say moderate to high. Um, you know, Depending on the industry, depending what you're doing in that industry, would define the general average for durations of projects. But for a 6-year duration project, I found that it required 18,000 tasks to service that 6-year project. So that was both all the phases of the project from start to finish, 6 years, 18,000 tasks. I started to dig further in and found that it had 17,000 resource assignments. So almost one resource assignment for every task. But what I learned is that they were not linear across all the different phases. As we'll see shortly on, you'll see that these are actually dispersed into very isolated phases within the project. Um, to service those 18,000 tasks, it required to be broken up into 4,300 WBS elements. So within 6 years, it had 4,300 WBS elements and 18,000 tasks within those WBS elements. What was surprising was that it had 44,000 relationships, so almost 2.5 relationships per activity. So to sequence those 18,000 tasks required 2,500 relationships. But again, those are not always concentrated linearly across all phases. They were primarily around the relationships between the end of a phase and a finished milestone. I also found there were 10,300 constraints, which I think is pretty normal. Obviously, you don't want to have constraints, but there are just certain activities that you just do not have control over. So, for example, supply says, I will give you this piece of equipment on Tuesday next week. There's nothing you can do about it. You have to put a constraint in there. But still, you want to keep that number right down. And this particular project had 1,300 constraints with it. Then there were other bits and pieces, float, paths, activity steps, and external relationships. 5 calendars I thought was pretty average. Sometimes they have a lot more if you exclude resource calendars from the mix. So that was the general construction of a schedule. But as you know, you would take this information, you would look at the best designed dashboard, but it's still the end of the day, 77% of those energy or these mega projects would go behind schedule. And when you're looking at the project, suddenly this makes a lot of sense. If you are looking at 18,000 tasks every month, that requires a lot of effort to do so. And are you also looking at 44,000 relationship changes? How are you managing that? For me, having spent some time as a planner in the past, I kind of got to a point where I understood that you're a really good planner can sort of plan between up to about 2 years. After 2 years, you start to then uh, um, sacrifice quality prediction over making provision for work. So, you know, after 2 years, your technologies are going to change, your efficiency is going to change, the available resources to do work is going to change. You're going to have new processes involved, and so after 2 years, it becomes very, very difficult to to plan it. But also, what I don't have any hard evidence to show this, but I felt that you know if you have a good planner who has to manage more than 50 tasks a day to update, then you start to also sacrifice quality of schedule updates. So if you have 18,000 activities, how many of those activities are all happening at the same time can become a concern. And you know I would think that if you have more than 50 activities happening at any time that need to be updated, you need to start hiring additional planners or schedulers to update them. So that was quite interesting. That's quite a large project. Depending, for example, if you are managing a power plant, for example, um, those that I've seen, the master schedules average between 5 and 8,000 tasks. Um, but if you are managing an outage project, which are shorter in duration, but they can go up to 15,000 tasks for a 6 month project. But nuclear power stations for an outage, they can go up to 50,000. So 15,000 to 50,000. I've seen physically work where you hit the schedule button and you walk and make yourself a cup of coffee, bring it back to your desk, and drink it before it finishes the process. So they all differ depending on the industry and what you're doing in that industry. But I think the average would be around about a 10,000 mark in terms of quantity of tasks. The other thing then I looked at was how it was constructed. So I try to find commonality between the different types of schedules. And what I came up with was this sort of visual. And what we were seeing is that we had this project management magic bucket at the top level where everyone was putting their hours on, where they were putting um, their meetings, they were putting on financial events, etc. And then underneath that, they were putting all their milestones. So what I mean by that, instead of putting milestones in all the different phases, they were taking all the milestones that were applicable to each of these phases and dumping into one WS. And that sort of um, provides you with sort of a illustration of the problem here around managing large quantity of schedules. Because if you have 44,000 schedules that are being delivered to you every month in an update, we soon see this situation where projects are being managed by milestone rather than the actual activity. So the activities are left to the planner to manage, with 44,000 relationships. And the project manager, or if I was to put it into it a different way, consider the conversation between a project manager and a planner. The project manager, he, she, or they, walks up, says, "Hello, Mrs. Planner. Um, uh, Apologies for the pronouns, but um, how are you doing? Tell me, when are we going to finish engineering?" And the project planner would say, "Oh, we'll finish at about February 2026." Conversation's over. They walk away. That's all the project manager wants. And that's what we are seeing here is they're clumping all of these milestones into one WBS and then having the rest of the work within the schedules. And we're seeing most of the resourcing, man hours, being applied to construction and engineering. Um, and not as much focus on the procurement, the manufacturing, logistics, site establishment activities in a master schedule. They all seem to follow predominantly this sort of process. The only outlier really was data centers. Maybe it's my poor knowledge of data centers as compared to oil and gas and energy projects. But oil and gas and energy certainly follow the same sort of process in terms of their level one miles, level one WBS. But then after that, it's slightly changed. So oil and gas prefer to use a discipline, so civil, mechanical, structural, piping, electrical, and instrumentation, assembly works, and all of that. They'd follow the discipline. Energy would follow different options, but would like to. What I've seen commonly is following a KK, well, it's what I call a Kraft. It's a German classification system, almost like the license plate or red plate number of equipments. So they break it up to functions, equipments, and then components of those equipments as a key as a registration. And they like to do it that way. And then again, data centers, I couldn't find any commonality. Really depending on what they were delivering. So if they were delivering a whole data center, they might break it up by systems such as cooling, power supply, etc. Or they might do it by, if it's a portfolio of projects, they were doing it by site. I couldn't find any commonality, but that maybe just was me not knowing that industry that well. So we know that schedules, these schedules are quite heavy in terms of the number of components and moving parts within them. So why are they uploading 12 schedules a month, and why are they so activity rich? And I started to look at a couple of reasons. I think there are more than what we're seeing here, but I'll go through some of them that I've listed here. But rather than just reading off, I'm actually going to take you through some visuals on them. So let's start with the construction life cycle. So when I say the life cycle, I'm talking about the early life cycle of the supply chain. So oil and gas upstream. I'm not talking about the midstream or the downstream. If it's power projects, I'm talking about generation. I'm not talking about transmission and distribution. I'm talking about that early onset of the construction work of the asset. So if we look at it in this way, in terms of the life cycle of a construction project, and I've oversimplified this for the purpose of this webinar. It's a lot more complicated than it is here. But in summary and in short, you do some exploration, you find some expensive asset somewhere unpopular or unpopulated, or deep at sea, or in the desert, or in the jungle, wherever, and you get rights to mine or do or build in that particular area. And then it's what we call FEED, or front end engineering design. And that's basically the process where they break up that whole build section of the upstream work into design, the buy, and the build. So they break it up into FE1, 2, 3, and 4, and they've got concept, feasibility, design, and build. And what we're seeing is that the contractors are starting to get involved a lot more in the design of a project rather than just the build. So what I mean by that is, if you are going to go and build something, it's really expensive to make mistakes. So what we're seeing is they are getting the contractors involved earlier on to make less mistakes, and that includes for planning in the design phase, rather than going and making those expensive mistakes when it's during construction and they're moving parts and it's high risk. But because of that, we're seeing a lot of the contractors' tasks end up in the whole design phase within the schedule that then lives with that schedule forever, and it becomes quite top heavy. There was a playbook, a construction playbook published by the UK Cabinet Office here locally, and it was government guidance on sourcing and contracting public work projects and programs back in 2022, and it set out 14 strategies. And actually, one of the very first strategies was how to get contractors involved earlier in the design phase of projects rather than later on when it's too late. But by doing so, obviously, the byproduct of doing that is that these schedules become quite large as they hold historic information about the contractor's involvement within the schedule. Um, the other thing to note is that by doing this, the contractor and the owner of their objectives, they're not diametric opposite, but they they are not the same. So a contractor is awarded a piece of work, and their objective is to complete it 100% and try and make this line as high as possible. The owner's view is actually this is an investment, so it's a negative value, and it's to try and make this as shallow as possible while still getting the contractor to achieve as much as possible. So if you were to look at it into more detail, this graph is completely fictitious, but it's for illustration purposes. You see FEL, so concept, feasibility, design, they get involved. So there's a cost involved in that. Now by having them early on, the investment grows, and the owner tries to promote or spend more money to get the contractors to accelerate to get more units online, so they can start to sell the products that they are delivering as their output, and get the rest of the units online. And as time goes on and the contractor aims for that 100% completion, it gets more complex. So they have this last push to try and get everything. It's the 80-20 rule. 80% of the time is taken to complete 20% of the work, because now you have uh, um, the owner's team on site starting to skill up, starting to own the first unit, starting to have live sites that have dangerous chemicals or powered systems running around while you're still building it. So you have to have permits involved, and it just becomes really more complex as time goes on. At the same time, that owner's trying to push for the work to be done so they can start to sell more product to where they get to a point where they break even. But in the future, they have to consider that they have to put the money aside for the decommission of that asset when it reaches its normal useful life cycle, when its useful life comes to an end. They'll have to actually spend money to decommission. In fact, where I grew up in South Africa, near Ladysmith, on the east side of South Africa, there was a project that I worked on called Ngula Power Station, and it's basically two dams at different grades, two different elevations, and during peak hours of need for electricity, they drain one to the other to generate electricity. And as part of the actual construction process, they may have said that as part of the process, you have to remove all evidence of work being done on the surface and move everything underground. So all the generation units were underground when we drained the water. So the only evidence that was there at the end of the project was the visitor's office on site. There was no evidence that there was ever a project being done there, and that was actually done as part of the construction build. So that actually becomes quite a cost to the end user. Another issue is when we talk about you know providing information in terms of context to the master schedule. So in order to understand that, you need to break down scheduling to its simplest form, and that is a task. If you look at a task on a schedule, no matter what product you're using, you're looking at it on a piece of paper. If you look at it in its simplest form, there are just actually two unique points to that task. It's the start and the end, and it's the only place where you can put these logical relationships. So there's nothing of interest along the way that you can use to build a dependency. You can't say when this task started, after 25% is done, then start the next activity. It doesn't work that way. It has to be a relationship to the start or the finish, as it's a relationship plus a lag or a lead. You can't use that as a percentage. And this leads to a problem where you have a task that makes provision for a certain piece of work. And then what the contractors do, rightfully so, is detail those tasks out. So for example, if this is the installation of a mechanical pump, they'll then have foundations, scrubbing, they'll have pump installation with cranes, and then they'll have here laser alignment and flange alignment and all of that. So they've gone and detailed the work so that they could actually break up this task into more pieces if they need to create a dependency between. So if these two here are done by civils and this is done by the mechanical another mechanical contractor, they need to find a breakpoint in here to be able to put in the dependency. But they don't have it on this task, so they break it out and make the dependency here. The problem is now when you put all that into a master schedule, what do you take up? That becomes it becomes a bit of a challenge, and it adds a lot more. You have 5 additional tasks where you could have just had one. The other interesting conundrum that happens when you involve contractors at the early stage during engineering is finding what we call this breakpoint. But in the industry, it's called meaningful levels of engineering or meaningful levels of material. So what I mean by that is you can't commission or pre-commission a project until you have built it, and you can't build the project until you have materials to build it, and you can't have the materials to build it, and you don't know what to buy through engineering. So when we start with engineering, they're looking for this meaningful point in which they can predict accuracy within schedules. So until they get to this point, everything is more or less just an assumption as to what it's going to take without knowing exactly what they're going to buy. And they're always looking for this break point so that they have enough information to actually buy material or put boots on the ground or dedicate putting boots on the ground. Um, that becomes a challenge. So what they're doing is they are adding in a lot of exceptions in their tasks as tasks, putting a lot more unnecessary information into their schedule that needs to be broken out into more pieces later on. Another consideration is the growing supply chain farm within a project. The owner has an interest to maintain a relationship with investors, the government, and obviously the general public, whatever they're building. And they would get the service of a primary contractor and maybe a turnkey consultant who they themselves would have access to a pool of highly specialist consultants. And then there would be a supplier matrix out there. And every time this gets bigger, you start to add more risk. And there's a fantastic book written a while ago. I think it was by a Danish economist, and they went and reviewed mega projects, hundreds and hundreds and hundreds of mega projects, and they said 92% of these projects were over schedule. And what you're finding now is that just by having these additional points, it's adding more risk to it. So it adds more points where things can go wrong. The other thing to consider is the actual communication between those different supply chains. So if you take the primary contractor, for example, the primary contractor will have a project manager or a construction manager, depending on the industry and how they manage projects and their processes. They get the project manager involved and then hire the rest of the team, and that would include supervisors, superintendents, quality assurance, quantity surveyors, etc., etc. Included in that would be contract managers, which I think are commonly locally referred to as CAMs. And the CAMs then would then set out to create relationships with the opposing contractors. Um, in some cases, that communication is quite highly regulated. So if they're using a methodology like NEC3 or NEC4, sorry, apologies, NEC4, you know, they it instantly creates a strong communication channel between contract managers and contractors. But what we're finding is that anything schedule related has actually been routed through the planner. So this planner is starting to create very heavy schedules for information from all the different contractors. Um, to give you an idea of the scale, there was a study done, and it was a paper published to the UK government by an organization called EC Harris LLP. It was called Supply Chain Analysis into the Construction Industry. And in it, it said to have 50 to 70 tier two suppliers and subcontractor is not uncommon. And they were basing that on an average build project. So an average building is a building project from 20 to 25 million. So fairly small if you compare it to some of the oil and gas projects or the power plant projects going on there. But even there, these contractors could go up to about 70. So for your engineering, could be a lot more. And it found that between 50 and 75% of these projects were done. These contracts were done by tier two contractors, and they would do 50 to 75% of all the work. So now you have 50 to 75 points of communication where the planner has to sequence them through the contract manager to get all the correct schedule updates. And it created more problems when it was compounded with three factors. Factor number one was the consistency of the information coming back to the planner. Factor number two was the format. So contractor one might provide you an XCR file. Contractor two might provide you a Primavera update based on printed out on PDF. And contractor three marks project. Contractor four an Excel spreadsheet. Contractor five doesn't even provide you and provides an email. So you were having inconsistent updates. You were having updates in different formats, and then the last one, the quality of the updates were quite poor. Or not always. So tier ones, they usually have a very they're very quite strict in terms of their policies and processes, but some, depending on the size of the contract or the experience, so you could get different levels of quality of these updates, not following the baseline, and that would just compound things, and the planner had to make additional tasks to make provision for this in their schedules, becoming, quite a lot. The other issue was once the planner had received the information, building the master schedule became quite an arduous process that took up a lot of time and effort, and meant that there was less effort available for checking quality. So when I say by that, so there's a master schedule that defines the master series of work, and those were then in the taxonomy, they would have these child projects as contractor schedules, hammocking their particular activities within the master schedule. And then every month that would be compared against the baseline. And what's happening, and it's quite often, quite common, you can go and you can go on the internet and check it out now. It's actually become quite a documented process. It's called this two-step update. And basically what the planners are doing is they're updating one, and then what they're doing is getting information from the contractor and just grabbing progress. So what had been completed over the last month and adding it to the master schedule. Then they would have to take another copy of the project and check the impacts of change. So a change could be a good change, something happened earlier. The change could be a bad change, something happened later. Or the change could be something that required additional investigation. And now they'd need to compare these two schedules, and that became quite a nightmare for the project planner. In fact, this is actually what I would consider more of a three-step process, because in the third process, you're actually starting to build your as-built program comparing to the baseline, so that if things would go sour, and as we know, things go sour all the time, the arbitrators will want to see exactly the as-built, and they want to have it in a separate folder. They want to have it in a separate location so they can go and review their, if it's a retrospective process they're using for delay claim, they want to go and make sure exactly what the information was at any point in time. So they're actually doing a three-step process and having a separate set of files for that eventuality. Not easy to talk about, but it happens all the time. Another issue we see is that we have information that's hidden and information that's shared. And this is around in the construction of a schedule. Let's talk about the master schedule. And what you're seeing is that you have two parts to this. You have information that goes into a baseline and an update schedule that is hidden to the owner. And then you have information that's going to the owner that should be there and maybe shouldn't be there. What I mean by that is, so the contractor gets a piece of work approved that they can do and gets a contract to carry them out, and they would apply a calculated method to understand, how they get to that that outcome in terms of the schedule. So they use drawings and designs. I know, a good planner knows that a bricklayer can do 1,000 bricks per day if unhindered. To install a magnetic pump between 0 and 5 meters grade is 7 direct man hours per ton. You apply those knowledge, those learnings from past, and you apply those calculations to the quantities from the bill of quantities. You also might also have to consider historic performance as well as what is available to you at the time. Um, so all of this information that's going into constructing a baseline is not known to the project, to the master schedule, and the master planner is making provision for those at some point. But then more information is once those is available into the planner, once it goes into, it gets the first update. They get suddenly a raft of information. I bet that if some of the contractors knew what was in an XER, they'd probably change their planning policy tomorrow morning. But you get a raft of information that's probably not really required or was not intentional. So you get this information that was not available and you have to make provision for it. And then you get information to you that you suddenly have to change and to put into your schedule. Are they managing multiple currencies? Are they making provision for um, known unknowns, schedule risk, hopefully, risk events, hopefully, unknown unknowns, set aside from profit. Profit is their USP, and they don't want to put that in the baseline. So they don't get this information, and it becomes then a challenge to understand what went into the baseline and then trying to reduce what goes into the update from the baseline. The last thing I'd like to talk about is the whole gig economy. And um, the whole issue around gig economy is not the gig economy, but the context changing. Anyone who's a developer out there, context changing is just the worst ever. Where you have to move from one context to another. The same goes for a planner. In 2024, the Deloitte released their construction industry outlook, and they mentioned that we need to embrace this gig economy. But it does come with its challenges. You know, the first one is obviously we spoke about was the supply chain growth. So you have more and more specialist um, contractors being cookie cutters to specific areas of the project, increasing the supplier farm. But you also have more and more complex software that is adding more barriers of entry. For example, if you were to install Primavera P6 today onto your laptop, it expects that you would know between 800 to 850 data elements long before you pick up a user guide or an administration guide, etc. We'll go for training. So the barriers to those things are quite high. And what we see is that instead of taking someone who knows the industry and teaching them the technology and sending them off for training on the technology, it's so big now, these technical barriers, that what they're actually doing is hiring technical people, and they're then becoming social uh, um, sort of they're adding social activities to go around asking the various key people, the sequence of events, and when's this going to, and how long is this going to take, and so they just become the more of a technical driver. Yeah, this then obviously is then compounded when they have to then take that information and then and move between not being a plan on one project, but now a plan on 5 different projects. So that planner now has high barriers of entry to a tool. So they're now a technical person, not an industry person, and they've got a growing capacity. They've got a growing supply chain, and importantly, they are context changing between the different projects that they have, and then they've got to try and communicate that back with a customer multiple times a month in a way that makes sense to them, and that's creating additional information and schedules that have become quite heavy. So we looked at a number of, and I think there's a lot more, and more time I'd spend on it, more I could better understand it. But we've looked at non-essential information in schedules. and every update, those updates could be good, bad. Especially difficult when we're driving slave schedules to master schedules. The planner not talking to the contractors, they're talking to the contract managers only. The supplier farm, the technical barriers, the schedules growing, and the context swapping from gig economies. And that's where I think nodes and links can help you provide, can be a value add to you, helping you understand what's in those very, very heavy, complicated, and ever-growing schedules. You need to have a nodes and links at your side to help you understand what's exactly in them. And we work with some of the world-leading construction companies and the big names around the world, working in almost every continent. Because we know that mega projects and context, and we provide our customers that visibility into their projects, just to establish a robust data and process governance to ensure there's predictability and enabling them to stay compliant and avoid these costly delays, and push these projects over line by having all that visibility. What you're looking at here is if I could put all the products into one page, this is the way I would do it. We break it up into 4. There's portfolio at the top. We have predictive AI on the left. We have generative AI on the right, and we have automation down here at the bottom. I'm not going to be able to show you all the products in the tool set today. I'm going to show you some of what I think are the key ones when investigating to understand what's in your schedule. So we'll start off with the portfolio management, and we'll work our way into the quality assurance. Sorry, I forgot where I put it. Checking schedule health to ensure that those quality of schedules are there when you're receiving from contractors. We'll look at the scope change, which I think is key in solving this problem, as well as the delay navigator to provide additional context. And as the world is moving on now with generative AI, we have our own large language model, and we have the AI agent, which I'll end off at the end of this the presentation. So I'll click in here and I'll get started. Okay, so I'm logged into Nodes and Links now. I'm at the portfolio view. So it's that bird's eye view looking down across all the different projects that I have been given access to or that I'm the owner of. I can see that I have access to 23 projects. 6 of those are delayed, and the overall score for the 23 projects is 88%. So the schedule health. And I'll get a little bit more into this, and we'll go into a bit more detail on this in the next few minutes. But from a portfolio view, I can see all those different projects, and it's a very, very useful view. I can expand on that and open up my portfolio to see more information about that. But in this particular case, we're actually just going to focus on one project. And let me go and open that project now. And it'll open up that specific project. And I'm going to go through only about 4 features today. I don't have time to go through the entire product. We need a lot more time for that. So I'm only going to go through at a very high level 4 features that help you understand why customers are uploading so many schedules. And we've already looked at, what are in those schedules and why they have been created. Now I'm going to show you how Nodes and Links can help you better understand what's in them. And there are 4 features that I would like to go through. So at the moment now, I'm on my landing page for the project, sort of like the home page, and it answers 4 very simple questions quite quickly. What's the progress? What is the sensitivity changes in 3 or 4 or 5 or 10 of what I picked as my most critical milestones? So in each update, have they changed? Up is bad, down is good in terms of the finish dates. So I can track key milestones quickly. I can look at the health, and I'm going to go into this in the next screens, and I can go and look at how my schedule compares as I've been updated month from the last update in terms of progress, duration, dates, and compression. The one I want to start with is health. So as health is loading, I started with the schedule in P6. You can see that here. So I uploaded a baseline at the start of the year. I had a baseline change off. It was approved to make some minor corrections. And then month on month, January, February, March, I've been uploading progress updates. We know that this might be a lot more per month, up to 22. But that's, we're looking at the two-step process, everything that we had covered earlier on in the presentation. I'm now in April, and I'm looking at my April schedule. I can start with health. So health is the schedule quality. It's not the quality of the progress of the schedule, but its integrity, how it was built. And I can see that I've got an overall score of 87.6%. In short, in the early 2000s, Defense Contract Management Authority released 14 tests for contractors trading directly with the US government over a certain value. These 14 published tests, 13 of which you can do in P6, set down logical tests to do two things. The first one was to allow those contractors to see if their schedules, when compared to an international standard, would stand up to scrutiny in terms of auditability, and secondly, and more importantly, stand up to change. So introducing a change to the beginning of the schedule, would it have an equal effect or logical effect to the end of the schedule, or would it not affect critical path activities, or affect something else in different ways? It wants to make sure that those schedules stand up to scrutiny and change. So it released these 14 checks. And what happened was the rest of the world saw this, and it almost became sort of a golden standard. So what we've done is we've taken this and pushed it and made it and taken it even further, because we want to help customers understand if their schedules will stand up to scrutiny and will stand up to change. So to better understand that, we have 13 you can do in P6, but we've gone and added an additional 29 tests that you can perform. So near critical activities, not just critical activities. We can look at duplicate activities, out of sequence. These are common tests, logical tests that you can run to provide you even a further granularity of checks to ensure that those schedules can stand up to scrutiny and change. And you could go and say, for example, picking missing logic. I can see that 17 out of the 72 tasks that I have missing logic, and here they are. So not only are we telling you the score, we're actually telling you which activities, so you can use this as the foundation to go back and change and update those tasks. But in some cases, you don't have to. So take, for example, prefabrication, for example. 2 out of the 14 potential tasks in this WBS were found to have not met the missing logic. And that was because it didn't have a predecessor, or this one didn't have a successor. But in this case, this task here is a WBS summary. And a WBS summary, its design is to summarize elements with the WBS elements within itself, not to have logical links. So it's irrelevant in that test, and therefore is it logical. So we provide you all the information to quickly go and find and update the schedule so that it can be strong against scrutiny and change. The next one is actually probably the more important one when it comes to understanding what's in the schedule, is understanding what's changed between one schedule and another. What I mean by that is comparing your schedule to the originally approved baseline, or maybe comparing it to last month's update, or if you're doing a two-step process, checking those changes without having to run complicated exports to spreadsheets and then run and create very complicated and error-prone formulas to identify all this information. We've done it in a very simple way for you to understand. So we can see that there are 5 tasks here on the critical path that have changed. Either something's been removed, so these ones have been removed, and these ones have been modified. And I can see that I can actually go and expand it to the whole schedule, because those are just really invoice milestones. So it's not really something that we want to track. But we can also go and look at the whole schedule that's not on the critical path. And we can see all these other tasks here. And I can see tasks that were modified and tasks that were unchanged. And then I can go and actually look at the changes. So red is bad, green is good. And if I look down the list here, this one here, so assembly complete, I can see is a massive 146 days delay. I can compare this to start dates, early dates, late dates, actual dates. I can compare the calendar. In this case, I see this one here, particularly caught my eye, is 146 days. So I simply have to click on it once. Now what we can do is take this even further. So we know that this task here, if I look here, has probably had the highest change. And I'm scrolling through. Rest seem to be improving or no change. This one seems to be the highest change. So I just clicked on it once and it copied the task for me. And I go over to my delay navigator. So now I know what's changed my schedule. I can pick the most, that's what I think was the biggest change there. And I can start to go and interrogate and understand what caused it and what contributed to the change. Knowing what changed and who's responsible is hard, but what the contribution to changes is probably even harder. So if I go and pick this task here, which I've pasted now, which is copied to my clipboard, I can see that there were 3 tasks that contributed to this task being delayed. And I can see 3 tasks, and I can see this middle task had the greatest contribution, 36%, or 52 out of 146 days delay that we saw. And if I click on that, I can see that there was a relationship change on that task which caused 52 days of delay. So there's actually been a relationship change. Now, if you were to do that into P6, and I've got this one open already here, you can see I actually did this one on purpose. I'll say I did it, but anyway, I forgot to add logical relationships from this task to have finished start relationships between different assembly works within the schedule. So I went and added them on this schedule, and it pushed the task right up to May, which is more or less when assembly is finishing, to the end of May. And that's why it was delayed. But looking at this view is so difficult when we provide you this information. And it really makes it really easy. You can see that contribution. So by adding that relationship to the task, this task here had the greatest contribution, 36% delay, and the biggest. But there was also palping painting, which is part of it, and installation and signage on module 2 also contributed to the delay of that task. So this is a very, you could follow the steps. We started with health. We went into what was changed. We picked up a change which caught our eye and went to Delay Navigator. A much easier way to do it is to use our AI agent. Now the AI agent is our large language module as part of our generative AI that looks at your schedule, understands the database of a schedule, and can interpret normal language to give you answers. So for change control, let's follow the same. So let's go from the other way around. So I could just go and ask here, what task is the most delayed? And I'll ask it in the normal language. It will then interrogate my schedule, come back, and give me and say, right. And we've seen this one. So I'm coming from the other angle. So that task here was the most delayed. And if I was to say, what caused the delay to that task, it will then go back and check what caused it. And instead of you just always giving you back text, it can actually give you the same information that we saw a few minutes earlier. So it gives me the ability to look at the same information without having to do all of that check. I can ask normal language questions rather than trying to build the same information from here, export it to a spreadsheet, or use Claim Digger, or use different tools, then to go and compare and come up with my own explanation. I can just ask simple questions to nodes and links, and it will provide me with that information. And you can download this. You can take this further. You can look at other areas of the schedule. You can go and compare progress, for example. So whether you're using unresourced loaded or cost loaded schedules, you can use the progress module, or if you're following earned value, you might want to use the earned value method. But you can quickly go and see now, as compared to your baseline, how you're doing from progress. So I'm currently just short of 65%, and the baseline says I should have been at 65.2%, so only 0.3%. But if I now go and expand it down into project management, it's a different story. It's an up and down process here where I can compare it, the actual work, against my early and late dates, and I can see that I'm actually far, far further behind. So this bow wave is starting to happen where early WESs are being delayed, and it's delaying where the rest are. Design engineering is dead on progress. Prefabrication, assembly, and transport hasn't started yet. Procurement is slightly behind progress by 3.9%. I can see my PI. I can see how many weeks behind, how many activities I have to deal with per day, so as a percentage. So you can use that information as well. But really, the four that we looked at today was the health, the delay navigator, the change control, and the AI agent. That's all we have for time for today. So I'm going to pop back over. Okay, I'm going to offer. Look, I mean, I'm always the planner. I'm on time and on budget, and we're just short of the hour there. So I think that was good. Before I open for questions, if you do have any questions, in the panel at the top there on the screen, there should be an option to ask your question. Just pop them over. In the meantime, I've put a link in the chat. If you also click on the chat icon, you should see one there now with a link to a survey. It's just a 2-question survey. If you have anything that you would like to see in the future, and we'd love to hear your feedback, please put it in. But yeah, we're just about on the hour. A big thank you to the marketing team, the silent heroes in the background that put this all together. Thank you all much for your time taking to listen to me moan on today. It was an absolute pleasure to have you and to present this to you. If you have any questions now, pop them in the chat, and I'll be happy to try and answer them the best I can. If I can't, I'll certainly get it to you as soon as possible. I'll give it a few minutes, and then if no questions, we'll wrap it up. Whilst we're waiting for any questions, if you're interested in what you've seen today and you see value, we would love to have a chat with you. Pop over to our website, reach out to me, and we would love to have a conversation and see where we can add value and listen to the challenges you're having in project scheduling and changes in schedules. This is the first in a series. We hope to have the next one very soon, probably around the same time next month. And the intention is to talk a little bit about resource efficiencies within schedule and how we can help you improve those efficiencies. Resourcing is a bit of a challenge. We're not seeing a lot of schedules being resource loaded because of a number of challenges, and I hope to share some of that information with you. No questions. Yep. So if you just go in the chat, if you pop them onto the link, and it will just redirect you to your page. I'd love to hear your feedback. Obviously, any feedback is welcome, and we'll take your comments on board. I'm going to be a strict planner and close the session at 6 o'clock. It's always a planner at heart. On time, on budget. If you do have a question and you didn't get a time to put in today, that's absolutely fine. Send me a message. My email is there, charles.wright@nodeslinks.com. and you can just reach out to me on our website as well, and I will definitely get back to you on any answers, any questions that you have. But we're at the top of the hour. I haven't got any questions. Thank you all once again, and hope to see you this time next month. Take care. Bye bye.